Hi everyone, welcome to this lecture. Now we have transformed our error into a loss function, which is a mean square error. Now the target is to reduce this loss function, and in this lecture we will learn how to reduce this loss function using least square method. Now student, why we reduce the loss function? So basically we reduce the loss function in order to reduce the error. When error is reduced, the performance of model is improved. Basically, when the model is improved or its performance is improved, it means we have adjusted the weight and bias of the model. So by minimizing the loss or by reducing the loss function, basically we are improving the model performance, or we are adjusting the weights and the bias of the model. So let's see how we can minimize this and how we can adjust the weight and bias of the model in order to get the improved performance from the model. So this is the least square method. So we define here least square method as a cost function or a loss function, and now we will reduce this loss function. So this is the step of a least square method, or here we have set up a least square problem. So you can see that it is a difference of y minus xw. Here y, x, and w, these are all the matrices. So this least square method is set up in the form of matrices. Y is the matrix of target value, X is the matrix of feature, and W is the matrix of weight. So if we multiply X by W, we will get the predicted value. So basically, inside this norm, inside this double bracket, which is called the second norm of Y and XW, and we are squaring it, we have the difference between the actual value, which is the target value, and the predicted value. So this is the way of setting up a least square method. So this is a difference and we are squaring it. Now, how to set up a least square method on a particular data set? So this is our multiple linear regression data set, and we can see that we have two features here, x1 and x2. So this is our output or y value. Now, this is the output equation or the regression equation for multiple linear regression, where W0 is a bias and W1 and W2 are the weight associated with X1 and X2. Now, how to set up a least square problem from this multiple linear regression dataset? So basically, we have to create three matrices. We have to create Y matrix, we have to create X matrix, and we have to create W matrix. If we go back and see the equation of a least square, we need three matrices, Y, X, and W. So we will create these matrices from our data set. So this is our data set. So how to create Y, X, and W? So this matrix will be Y. The matrix of a salary or the output variable or the dependent variable will be Y. The matrix of the features will be X, and the matrix of the weights will be W. So this is our Y, this is our X, and this is our W. Now, we have to note the dimension or the sizes of these matrices. This is very important. Here we have 5 samples, therefore the size of Y matrix is 5 by 1. Now here we have 5 samples, but we have 2 features. If I go back and see, we have 2 features, x1 and x2. So these features are present in this X matrix, which is the matrix of feature. So it has 2 columns and 5 samples, so its size is 5 by 2. It has only 2 values in the row, so there are 2 rows and 1 column. So this is our weight matrix. Since we have 2 features, therefore we have 2 weights. Now we know that in least square method, we have to multiply X and W. If we go back and see, we have to multiply X and W in order to get the predicted value. So in order to perform the multiplication, the column of X matrix should be equal to the row of W matrix. That is, we have 2 columns here and we have 2 rows here. It means now here the multiplication is possible and the condition for the multiplication of X and W is valid. Now this is Y, X, and W, 3 matrices for a small data set having only 5 samples. Let's transform this into a general equation. Suppose we have n number of samples. Rather than 5, we have n number of samples and we have D features. So in that case, this is the size or the dimension of Y, X, and W. Now Y will be n by 1. Previously, it was 5 by 1 because we had 5 samples. Now we have n samples, so the size of Y is n by 1. Previously, the size of X was 5 by 2 because we had two features. Now we have n samples and we have d feature. Therefore, the size of X is n by d. Previously, the size of this W matrix was 2 by 1 because we had two weights with the features. Now we have D features, therefore we have D weights from W1 to WD, therefore the size is D by 1. Now if I see the size of X and W, the multiplication is still valid because X matrix has D column, whereas the W matrix has D rows. So the condition of multiplication is still valid. Now there is problem here. The problem is this is the matrix of weight, but there is no bias inside this weight matrix. So if I add bias here, then the dimension of this matrix will change. Look at here. Now, if I add a bias term in the matrix of a W or the matrix of a weight, now its dimension will be changed from D by 1 to D plus 1 by 1. So previously it was D by 1. When I insert a value of a bias in this matrix, its size becomes D plus 1 by 1. Now it becomes D plus 1 by 1. So if it is D plus 1 by 1, then in order to multiply it with X, we have to transform this D into D plus 1 as well. So how to do this? So basically, in order to transform D into D plus 1, so that we can always perform the multiplication of X matrix and W matrix, I have to append 1 in the first column of X. You see, previously this 1 was not present in the feature matrix. Now I have append 1 at the first column of this matrix. Now the one column has been added. So the dimension of column of this matrix has increased from D to D plus 1. So when we insert the value of the bias, in that case, the dimension increases, and in order to keep the multiplication valid between X and W, we have to append 1 at the first column of the feature matrix. Now the problem has solved. We have insert the value of bias and we have set the dimension size which are valid for the multiplication of X and W. So before going further, let's understand what is the shape of our least square function. So this is our least square function. It is a square function. So it has convex shape. Look at this shape. This shape is a convex shape. Now, what is the advantage of convex shape? Basically, we want to minimize this value. So the advantage is in a convex shape, we have only one minimum value, which is at the bottom of the function. Now, if I want to reach at this point, I have to take the slope of this function. This is the point in the function where the slope is 0. And this line has a slope, this line has a slope, but at this point, the slope is 0. So in order to find the minimum value, which is my target, because I am going to reduce the error, I am going to find the minimum value of error, or I am going to find the minimum value of my loss function. So for this, I have to reach here. In order to reach here, I will take the slope of this equation and put it equals to 0. When I will take the slope and put it equals to 0, I will be at this point, which is the minimum point, and then my problem will be solved. So in order to go further in the mathematics, it was important to get the concept of a least square function. That least square function is a convex function, and the advantage of convex function is there is always one minimum value, and that value can easily be obtained by taking the slope of the loss function and put it equals to 0. So this is the step which we are going to do. Let's calculate the slope of this least square function and put it equals to 0. So this is our least square function. Now the next step is we want to expand this into two brackets. Now this is a square. If I want to expand it, this is basically the dot product of two brackets, that is y minus xw transpose and y minus xw. So here is the expansion. Now we want further expansion. We want to open these two brackets. So it will be open like a minus b whole square. So this is our a, this is our b. So this is a square plus b square minus 2a and b. So here we have opened this according to the famous algebraic equation a minus b whole square. So a square b square minus 2ab. Now here there is also a square. Now we need to expand this term as well in the similar way as we expanded this. So this square will also be the product of xw transpose and xw. Now we assign this to each value inside the bracket. So it will becomes W transpose and X transpose. And this is our XW. The next step is to arrange the term. Now we will move this W close to this W transform. So here we have moved W close to W transform, and here we have XT and X, and there is no change in these first two terms. Now we have W transpose and W. If I multiply these two, I will get W square. So we have reached to the expansion form of our least square function, and here is our loss. Now it's time to take a derivative. By taking a derivative, basically we are calculating the slope. And we have learned in the pictorial view of a loss function that it is a convex function. And in order to reach the minimum value of a convex function, we need to take the slope and put it equals to 0. So in order to calculate the slope, what we are going to do, basically we are differentiating this equation with respect to W and set it equals to 0 to find the minimum value. Now take the derivative with respect to W. So this term doesn't has any W. It will be considered as a constant for differentiation. Therefore, it will be equals to 0. So we will remove this. So this is term which contains W. So the derivative of this term will be 2xty. Similarly, this is W square. So the derivative of W square will be 2W, and xt and x are there. Now here we are putting this equals to 0 in order to find the slope or a minimum value. Now in order to simplify, we dividing this equation by 2. Just divide this equation by 2. So 2 will be removed and we are left with x transpose y plus wx transpose x is equals to 0. So this is negative term. We will move this negative term to the right side of the equation. Now student, target is to find the optimal weight. As I told you at the start of this lecture that we want to reduce the error or we want to reduce the cost function. So why we want to reduce the cost function? Basically, we want to reduce the cost function to improve the performance of the model. And the performance of the model depends upon the value of the weights and the value of the bias. So basically, if the loss function is reduced and model has achieved its maximum performance, it means we need to calculate the new set of weights, or we need to calculate the optimal set of weights and bias. So if I want to calculate the optimal values of weight and bias, I need to move xt and x towards right side. So when I move these, since these are matrices, by moving from left to right, we have to calculate the inverse. So this is the final form of least square. So we know that whenever a data set is given, we have x and we have y. We only need x and y in order to get the optimal value of the weight. So student, this is the least square solution. In this solution, we have the minimized value of the error, and the weights and the bias obtained by using this method are the optimal values of the weight and bias. So in this lecture, we learn how we use least square method in order to reduce the value of the cost function. We want to reduce the value of the cost function because we want to reduce the error. We want to reduce the error because we want to get the maximum performance or the optimal performance from the regression model. Since regression model is a machine learning model, so the performance of regression model will be improved if we adjust the weight values and the bias values of the model. So everything about the performance of regression model depends upon the value of the weight. If the model is not performing well, it means we need to adjust the value of its weight and bias, or we need to find the new or the optimal value of the weights and the bias of the regression model. So we have found the optimal value of the weights and bias of the regression model using this least square method. So in this lecture, we learn how regression is performed using least square method, how the cost function is reduced using least square method, or how least square method is used to find the optimal value of the weights and bias. So when you solve this value, you will get the optimal value of the bias and the weights of a regression model. So that values of the bias and the weights are called the optimal value, and those values will representative of the best regression model. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.